Section 4.5 is on integration by substitution. The first one here is asking us to integrate the cosine of 4x minus 1 dx. So we know how to integrate cosine x. So if it were cosine x, we would just be able to integrate it. If I have like the integral of x to the fourth dx, that's something you know how to integrate. The problem is if I have something other than just x to the fourth, if I have 3x minus 1 to the fourth, you cannot integrate this in the same way you do this. Basically, if you would need to use, if you were taking the derivative, if you would have had to use the chain rule or the product rule or the quotient rule, any of those, there's not rules like that for integrals. Instead, we're going to use this process, integration by substitution. So let's take a look. Usually the first one can kind of be a little confusing, and then once you start to get the hang of it, it's not too bad. So it's asking us for the integral of cosine of something other than just x. So what we're going to do is we want this to eventually look like the integral of cosine and just a variable. And usually we choose u as our variable. So we're going to make u equal to 4x minus 1. U equals 4x minus 1. And now it'll say the integral of cosine u. The problem is right now it says integral of cosine u, but then this here doesn't change and it's a dx. So my variables don't match up. This is a u and this is an x. So what we're going to need to do is we're going to need to change this to a du. And the way we do that is we take the derivative. So this would say du dx equals 4. And then we're going to multiply the dx over. And we'll do that every single time. So this is going to say du equals 4 dx. So to change this right here to a du, I need 4 times dx. Well, I don't have 4 times dx, I just have dx. So I can multiply by 4. The problem is that changes my problem. As long as I also multiply by 1/4, now my problem's the same because I have times 4 and times 1/4. So this right here, 4 times dx, that is the same thing as du. This 1/4 I'm just going to bring down, and a constant, a number you can move out front, that's fine. Times the integral of cosine, and instead of 4x minus 1, 4x minus 1 is equal to u. So right now, this is now something I can integrate because it's no longer cosine of 4x minus 1, it's cosine of just a variable, cosine of u. The integral of cosine is sine. And we don't want that to be our final answer because there weren't any u's in the problem. We introduced u, so our final answer should have x's in it. So plug 4x minus 1 back in for that u. 1/4 sine of 4x minus 1 plus c. Hopefully that made a little bit of sense. If not, let's try another. Example 2 looks like this. It is the integral of x squared times the quantity x cubed minus 1 to the 4th. So I've got something more than just an x to the 4th here. I also have a product, x squared times this guy here. So I can't integrate it as is. When that's the case, usually we will use substitute. In this case, I want this to just be u to the 4th. So we're going to make u equal to x cubed minus 1. I need to change that dx to a du. I do that by taking the derivative. Du equals 3x squared times dx. So to change to du, I need 3x squared dx. Well, I have x squared times dx. So I need 3x squared times dx. So I'm going to multiply by 3, which I'm allowed to do as long as I also multiply by 1/3. And now we want to rewrite in terms of u. So the 1/3 is coming down. 3x squared times dx. 3x squared times dx is all equal to du. So all that stuff I circled is built into this du right here. And then I've got x cubed minus 1 to the 4th. X cubed minus 1 is the same thing as u. Now I can integrate it. Now it's the integral of just u to the 4th. We know how to integrate u to the 4th. The integral of u to the 4th, add 1 to the exponent, and divide by that guy. 1/3 times 1/5 is 1/15. I've got u to the 5th plus c, and u is the same thing as x cubed minus 1. Let's do one more like this. The integral of x squared cosine x cubed plus 1 dx. So after you've seen a few of these, after you've practiced a few of these, you'll start to get the hang of what to make u. In this case, I want cosine u. So I want u to be x cubed plus 1. Therefore, my du is going to be 3x squared dx. To make my du, I need 3x squared dx. I've got x squared dx, so I need to multiply by 3. If I multiply by 3, I also need to multiply by 1/3. 3x squared dx, there's du. My 1/3's coming down. And I've got cosine u. Integral of cosine is sine. And plug in x cubed plus 1 back in for the u. Example 4, this one's just a little bit different in that we have these bounds here. So I've got the 0 and the 1. But we're going to do it pretty much the same way. I've got the integral from 0 to 1 of x times the quantity x squared plus 1 cubed dx. U equals x squared plus 1. Du is the derivative of that, which is 2x dx. There's x dx. We need to multiply by 2 to make du. So we also need to multiply by 1/2. So I have 1/2 2x dx. All that's du. Got u to the 3rd. Integrate. And plug back in. The only thing that's different now, instead of putting a plus c on here, I have this definite integral. So once I've integrated, we actually don't need the plus c. Now is when we plug in 1. So I have 1 plus 1, 2 to the 4th is 16 divided by 8. So if I plug in 1, I get 2. Plug in the bottom one, gives me 1 to the 4th times 1/8, and subtract. So it's similar to what we did the previous class last week, where you plug the top one in, plug in the bottom one, and subtract. You just need to use substitute in order to integrate first, in order to get there. So what is that? 1 7/8, 15/8. One more example, last one. Integral of x times the square root of x minus 3 dx. I'm going to rewrite it like we usually do. Instead of x minus 3, we're going to write it as x minus 3 to the 1/2. Looks very similar to the other problems we've done, so we can make u equal to x minus 3. So du is 1 dx. So in this case, I don't need to multiply by anything. I already have my du. It's right there. This one's different, though, in that when I go to rewrite this, so I've got dx is equal to du. This is u to the 1/2. The problem is I have this x, and on the previous examples, it became part of the du, but this time it doesn't. Here's my du right here. So I still have an x in there. When that's the case, what we'll do is we'll take this equation right here, and we'll solve it for x. So if I add 3 to both sides, it would say u plus 3 equals x. So I can replace x with u plus 3. I'm still multiplying here, so I can't integrate yet. We're going to distribute this. When I multiply, I add exponents 1 plus 1/2, 1/2. Here I've got 3u to the 1/2, and now it's something we know how to integrate. Add 1 to the exponent. And divide by that same thing. So here, divide by 5/2 is 2/5. Divide by 3/2 is 2/3. And again, change back to x. So we have 2/5 times u, which is x minus 3, to the 5/2, plus 2 times x minus 3 to the 3/2, plus c, and that's our answer. There it is.